Grounding properly can solve many problems in coding. In fact, it's the difference between being a master of tasks or being a servant to a taskmaster. How will you ever know your codings are good until you get it just right? Fear not the Reaper, my friends. We've got John Cole, president of Parker Ionics, to decipher the code to great ground. He answers your live questions from my group posts on Facebook. Plus, we get a hat tip from the market maker about our podcast and the impression it's making in the industry. Get ready to level up your powder coder game.
Hello.
Hi, John.
How are you?
I'm good. How are you?
Good. Let me turn on my camera here so you can see who I am and where I am.
There you are.
Yeah. So it's good morning to you right now, right?
Yeah, it's 10 o'clock.
All right.
And it's like what, the end of the day for you, right?
Oh, yeah. Well, I've got a 7 o'clock Zoom call with Japan tonight. So
oh my goodness.
For a while.
Oh, yeah, they're like a whole, well, here in Hawaii, it's like when I went there, it was like a day and a half difference. Yeah.
Yep. Yeah. So right now we're 13 hours time difference. So when I call at 7 o'clock tonight, it'll be 8 o'clock Friday morning for them.
Oh, wow.
Yeah.
Yeah. Well, I'm super stoked to have you on the show. So let me get right to it. I want to introduce John Cole from Parker Ionics. I actually attended, because we're PCI members, and I know you through PCI. Oh. I actually attended a grounding webinar you had a couple weeks ago, and I found it so interesting, your slides, and had so many more questions and stuff. And I know in that webinar, there were line coders and maybe some batch coders and stuff, custom coders. My audience here at the podcast is mostly guys, that are kind of maybe early on in their operations, maybe experiencing production issues or operational issues, process issues and stuff. So, I found a lot of your visuals really good. So hopefully, and in fact, what I'll do right now is I'll allow you to share your screen in case you do want to share some of your images from your webinar. I think the visuals you presented there were really good. Of course,
let me find those real quick. That sounds good.
Yeah. Okay. And while you're doing that, I want to share my screen right now because I want to bring up your website so that we give you some kudos and stuff about Parker. And so let me do that.
I got to figure out how to change screens here because now I can't see you, but I can see my presentation on my screen. So
right, and I think I just have to allow you. But right now I'm sharing my screen so we can you see Parker Ionics, your website?
I sure can.
Yeah. So I just kind of want to introduce you a little bit. I know you're the president of Parker Ionics. Again, so happy to have you on the show and have you share your deep knowledge of powder coatings in general. Maybe get you on a couple more times after this to talk about we always end up thinking, hey, we could talk about this next time. So if you have a good time, please come back. But I do know you through the Powder Coating Institute. I've attended a few meetings with you in there and stuff. But tell me how you got started, just maybe a brief description of your industry background and what you like about powder coatings, how you ended up at Parker, that sort of stuff.
I'd be happy to do that. So first of all, I've been at this since 1972. I'm an old guy. I spent 35 years with a company called Choline Corporation, where one of our products was paint stripping molten salt. So I spent 35 years taking paint off of parts. And since 2007, I've been putting paint on parts. So I know both sides of the equation there. And with my time at Choline, trying to justify the high cost of molten salt for stripping, which, by the way, is still the best way to strip paint. But I really tuned in on how important ground was. And a lot of the presentation that I do, a lot of the data in it comes from some ground testing we did at Choline Corporation.
Yeah, I found that compelling. I found that very compelling, that testing.
I'm telling you, the data is there. So I'm a ground fanatic. I'll start out with that. I preach ground when I teach classes. One of the first things I say is, in this presentation, you're going to hear me say the word ground at least 50 times. And then I went on and did the presentation. At the end of it, one of the students in the back of the class raised her hand and she said 53. And it'd been a while since I said I'm going to say it at least 50. I said, what do you mean? She says, you said ground 53 times. So in fact, one of my presentations is called Ground Ad Nauseum, because in my humble opinion, and based on my experience both at Choline and at Parker Ionics, I personally think there's nothing more important to powder coating success than proper grounding. You can paint, you can powder coat without ground. I can show you how to do it without ground. Powder will stick. It doesn't stick effectively or efficiently. But I mean, without ground, you can still get powder to stick. And that's why when people are running their lines with no ground, and I can prove it to them, they got no ground, they're not bothered because paint is still sticking to the parts and they're getting product out. The product they're getting out has film thicknesses all over the map. And oh, by the way, in doing that, they've wasted a heck of a lot of powder because the transfer efficiency is terrible with bad ground.
Right. Yeah. And maybe we can talk about what is too much or not enough or whatever. I mean, remember that most of my followers are probably batch coders. I'm not sure we have line coders. So let's keep that in mind when we're going over your slides. Do you want to just start getting into them now?
Well, let me see. Yeah, I can. But see, my problem is I'm trying to figure out how I can. I
think you go down to the toolbar, and then there's in the Zoom meeting, and then you click screen share.
Oh, there we go. I got you back. I didn't have you for a minute, so now you're back. So I can do screen share.
Yeah, I've allowed you to share it.
And let's see. Now, are you seeing my presentation?
Yeah.
Okay.
Yeah,
so,
looks great.
So, here's how I start. I have a mantra. Ground is important. Ground is very important. Ground is extremely important. And then I think the next slide, it's arguably the most important aspect of successful powder coating. And I capitalize successful because, again, as I said, you can powder coat without ground, but it's not viewed as successful powder coating. And this talk is really aimed at the batch guys. It's aimed at the DIY guys. I have a really strong part of my heart for the guys that are just starting their own shops up and that. And I really do this presentation to get them to fully understand from day one how important good ground is. So.
Yeah, it is.
And so, there's, for those who didn't see my webinar, the first point on here about Tom Frauman's article, it pays to become a ground fanatic. That is literally the best article I've seen written on ground, bar none. I mean, he goes through transfer efficiency. He goes through all the things that kind of I lay out in my more modern presentation. That was done back in 1996. So
yeah, I'm wondering if there's a link to that or something. I was going to ask you, but
it was published in Powder Coating Magazine. So
yeah, I think they're done now.
They're gone.
Yeah.
So I mean, I can get to you. It's a Xerox copy of the article.
Yeah, we can just scan it, and yeah, exactly. We'll scan it, and then I'll pop it into I have a vault.
Okay.
Where people can, put their email address in, and they get a vault of, we're kind of creating the vault now. It's just starting out. I'll put that link in there, and then that article, if we can find it, will be in the vault.
And I'll do that when we're done today. I'll get that off you right away.
Yeah.
Some of just a point of reference. What is ground? Ground is a common return path for current. It's literally something in earth ground. Okay.
Yeah.
And then it also limits the buildup of static electricity. There's 3 different aspects in this presentation I talk about for ground. One is safety, because safety is number 1 anyways. One's quality, and then the other aspect is cost. From a safety point of view, you don't want to have a fire start. You'll never get, I should never say never, okay? There's no probability that you'll get electrocuted from not having ground parts, but you could get a discharge. And I tell people this, especially the batch guys, they paint a whole cart of parts and they don't have a good ground. And then they go to grab the cart handle to pull it out of the booth and put it in the oven. And they get this snap and they get this poke. That's literally a complete cart that's full of ions, surface ions that have nowhere to dissipate because there's no ground. When you reach your hand to the cart, you are presenting that cart full of ions with a ground path. And so literally all the charge from all those ions is jumping to you. And that's not ever going to kill you, but it's going to startle you. And if it startles you enough, you're going to end up falling down, breaking an arm, breaking a leg, whatever. So,
yeah.
And then on the quality side, people are always worried about Faraday cage penetration. They're worried about back ionization, especially some of these small wheel shops. If you're looking for a real smooth clear coat on top of a color coat or a translucent, you're going to have a hard time getting that smoothness if you don't have a good ground path.
Right. So when you're talking about that, you're talking about like that orange peel. Is that what
Yeah, if you can see right on here in this front sample. Yeah, back ionization is orange peel. So it's something that nobody wants to see on their nice shiny wheels, right?
Well, we just blame the powder supplier, right?
Well, and in all fairness, there are times when you can blame the powder guy because you can get orange peel or that orangey appearance also from wide swings in particle size in your powder. So if you've got a lot of 40 to 50 to 60 micron particles and a lot of 10 to 20 micron particles, they flow out differently, and you can get orange peel from that. Most generally, we're talking electrostatic orange peel from excess freon.
Right. Is there a visual difference between those two? Like the particle micron, you couldn't tell, so you just, okay.
Yeah.
Well, that might be a good topic for a future podcast.
and honestly, I mean, I'll send you some names, but there's one person I would put on a podcast to talk about powder-related defects, and I'll talk to you offline on that.
Yeah.
I think there's a lot your audience could learn from someone who's really well-versed on powder chemistry and how powders flow. The small DIY guys have ovens that don't recover temperature fast. And if the temperature doesn't recover fast in an oven, then flow out is all different. And you don't get the characteristics that you want from the powder. They're all designed to recover quick. So.
Right. And the whole point of the podcast and why we created it was to, that there's a huge informational gap. We're trying to address that through PCI. Yep. And we're trying to tease out, because custom coaters are still to this day left out in the cold sometimes. And we're having to create our own ways and methods to processing aside from the differences between line coaters and powder coaters at the get, we want to tease out some of the best tips and tricks from that part of the industry to utilize in our own, our own operations. I actually just interviewed Denny Young from DJ Powder Coating, who actually did a brilliant way of racking using line system racks to improve his own batch production, because he's just a batch coder. So that was the earlier podcast. So if you haven't heard that podcast, please go and check it out, because it's really where I kind of came to the understanding that we actually need to grab it from you guys, from the line coder guys, and bring it down to our level, to our benefit,
There's a lot to be said about that. Because I said I have a special place in my heart for the DIY and the startup guys, I do follow a lot of these Facebook blogs and that. And and you're addressing this, but one of my big issues is there's a lot of people throwing out a lot of information that frankly isn't true. I mean, I start reading some of this stuff and I'm thinking, okay, should I jump in here? And my fear, every time I jump in to put a comment in from a professional's point of view, it just seems like I get inundated with people that argue on both sides,
right.
Oh, that guy's right. So yeah, I appreciate what you're doing with these podcasts here, and I'd be willing to help out any I can.
Yeah, I actually just saw a comment that I had Chris Redding on very smart guy. We had him on, I don't know what the episode was, but they've got the Pure Clad that they're introducing for the wood coatings, coatings on wood and
our new
cabinets. Yeah. And, we answered a tech question from a viewer or a follower of ours, and Ross gave his perspective. And then I had Chris actually commented. So if you go to the YouTube channel, you look at our Coder Tech News segment, which was a few weeks ago, he actually just replied and had another perspective, and it was a very good perspective. So I think people, I'm just shout out to Chris for commenting and explaining things from a more higher level, I guess, than a DIY level, to kind of understand the chemistry and what happens in the bonding process and stuff like that. So, or the inner layers.
Chris was a fellow PCI board member with me, and actually he was president during one of the periods I was on the board. And I do have a lot of respect for him, and I would trust his knowledge.
Yeah, it was a very good explanation, and I just want to say thank you, Chris, for doing that. But let's get back to this website, webcast. So on grounding. So there's safety, quality, and then you didn't address costs.
And the cost side comes from the transfer efficiency aspect.
Mm-hmm.
Okay, your transfer efficiency is really low on ungrounded parts. Fundamentally, and I don't want to get into it on this one, but fundamentally there's a law of physics that guides us in powder coating. That's Ohm's law. And your voltage is a potential energy. Your kinetic energy, the energy that does the work that creates the charge, is your current flow. And so what transfers the potential energy to kinetic energy is the introduction of a ground in front of your gun. Your ground then will allow current to flow from the electrode to your part. Okay, so if you got a good ground, you got a really good transfer from potential energy to kinetic energy. If you've got a poor ground in front of it, then you're not going to get that current flow to start effectively, and therefore you're going to get a degraded transfer efficiency.
Mm-hmm.
So,
and it's so hard because you can't see it, right? And if there was, you cannot see these forces at work, and if you could, you'd understand it maybe a little better.
Well, so here's an example I use when I teach inside the booth. if I'm triggering my gun out in the middle of the booth with no parts around it at all, I show them that the current flow on the controller is very low. The microamps is very low because there's no ground to create the flow of ions, okay?
Mm-hmm.
However, my hand will become the color of the powder coming out because my hand presents a ground to the electrode. It's not a very effective one or a very efficient one, okay, but it will start that minimum current flow. And of course, then you'll get the wrap coming back with the powder onto your hand. So if a painter's in his booth and he's got a bare hand and his hand is the same color as the parts he's painting, that's a telltale sign that you've got a bad ground on your parts because your hand's a better ground.
Yeah. I think I don't want to stop the this again, but I have seen in the groups a guy had posted just this week, which was so ironic because it always kind of happens right as we're getting ready to do some kind of a podcast on something similar or, the on grounding or whatever, but he had powder all over his face. And, I know he was, I don't know what the situation was. He was just saying it was a busy day at work or whatever. And I'm thinking, are you sure you checked your ground?
Well, and I guarantee you he's not targeting his face with the gun. He's targeting away from his face to a part that allegedly has a good ground. If it had a good ground, all that powder would go to it. None of it would come back to him.
Right. So I worry when I see posts like that. I mean, we're not sure he was, making a joke or cracking a joke or something about how busy it is. But I really do think that you should be checking your ground. And I also believe that some people are not grounded enough personally. Like, I don't know if this kind of relates to, I think you had brought it up in the webinar that I had talked to, that I had attended. And it was like, if it's, Ross thinks that it actually has something to do with your personality too. But that's kind of getting woo-woo there. But some people just aren't good coders, right? I mean, as much as they want to be in this business, there is a certain kind of flow that the human being has.
Well, I think a lot of it comes down to, let's talk about your footwear. If your footwear is rubber and insulating, then you're not actually in contact with ground. You do have, as long as you have a good gun, if you're holding onto the handle, that's giving you an electrical ground. It's not a true earth ground, but you'll have some ground. But if you're wearing rubber sole shoes that are insulating to ground, you're going to be, your body, the majority of your body is going to be electrically above ground, and you'll get a charge built up on you. So.
Oh, interesting. So what are you recommending for footwear then?
Well, I'd use any leather soles, anything that's conductive. I see people standing on mats in a booth. The stress relief mats.
Yep.
If those aren't conductive, you're actually putting your body above ground.
Wow. Okay. Wow. That's a good tip. All right. Well, what's next?
So, I go into, here's a point that I've started making. It should have a huge impact on people, but it doesn't. NFPA 33 says that anything that's conductive in a powder booth must have resistance to ground of less than 1 megohm, okay? If you've got parts that are coated or hanging on coated hooks, they do not give you that requirement. Their resistance to ground is up. Some of it's infinite, and a lot of it's way more than one megohm. So technically, if you're powder coating in a booth with ungrounded parts, you're violating the NFPA 33 code. And also the OSHA code, because OSHA's 1910-107 says the same thing. That goes in one ear and out the other for the most part. But I just like to bring it up because, everybody says I've got a good ground. Well, you don't, and here you're in violation. Selling an end user, selling the point that ground is important and ground should be really paid attention to every part you're painting. Everybody says, I've got good ground. I say, you don't. And then I say, here's what you need to do. And then they say, well, I can't afford to do that. And my point is, for any number of reasons, you can't afford not to do it, whether it's safety, whether it's quality, surface quality, or whether it's cost. You literally can't afford not to present a good ground.
Right.
Okay? So
right.
it's a hard sell. It's a hard sell.
Yeah.
I teach classes and everybody walks away from my class going back to work telling the boss, we need to get better ground. We need to clean our hooks more often. We need to do this. And they get that, deer in the headlights thing. We can't afford to do that.
Yeah.
So.
Yeah, I think it's important. And I also think that if we could as a group, know that, then maybe we could charge higher prices too. I mean, instead of the $50 rim, guy, maybe you should be charged because that you are providing a better ground and a better quality finish.
Well, and you shouldn't have to really point that out because your quality will be much better than someone trying to put a nice coat on aluminum wheel without a good ground. I mean, that would sell itself. But in a conversation, if you're a painter of wheels and you're doing high quality work and you're higher than everybody else, part of that argument could be, we use fresh hooks on every wheel we coat because we know we need a good ground to get the high quality. And it's actually, it's actually better for us to do this. And does it cost a few bucks more? Yeah, but the cost is going to be reflected in the quality. So
right. Absolutely. Good point.
This what's up there now is a Megger. And everybody has the misconception that their little 9-volt conductivity tester isn't good. It's actually the opposite. The Megger will show a ground that a 9-volt voltometer won't show. So it's really giving you a better indication of good than a worse indication of bad. So the megometer, there's not a doubt in my mind, every shop should have one of these. They cost anywhere from $200 to $500. Ours is, this Amprobe you can pick up for $350, $375. It has 500 volt and 1,000 volt. What a Megger does is it measures the resistance at a higher voltage. So whereas a 24 volt might not find a ground, 1,000 volts, you'll get some current flow, which will then say there's low resistance.
Good to have. Okay.
The other thing I point out is there's a difference between conductivity and ground. If you put your Megger between two pieces of metal and it says 0 ohms, that doesn't tell you have a good ground. It just tells you that there's 0 resistance between those 2 points. If neither one of those points is connected to an earth ground, you have conductivity, but you don't have ground. So that's when I did this presentation, I really went a little deeper than we normally do to try to get the point across. I use this slide here to show the ground path. Here the ground path comes through this wire to a clamp that's clamped onto the rack that then has got parts hanging from hooks. So anywhere along this ground path, so the ground path is part to hook, to rack, to clamp, to cable, to the booth, which on the other side of the booth where this wire comes through is a wire that goes literally to a 10-foot deep ground rod in the ground. That's the ground path. There's any number of ways that ground path can be degraded. If I have dirty hooks, I don't have a ground path. If I have a dirty rack that doesn't have bare metal to present to clean hooks, I don't have a ground path. If I connect my clamp up to a portion of the rack that's got powder on it or cured paint on it, I don't have a ground. And going all the way back. And I like to say, check your ground path every time and also check it back at the ground rod because the ground wire could have come disconnected. Ground rods are copper. Somebody wants to steal copper and make $2 off of it, they'll steal your ground rod. So you always want to verify that ground path, part, hook, rack, clamp, wire, goes all the way back to a rod that's in the ground. A lot of people say, well, why can't I sink a ground rod right in my booth? And the answer is you can, but many buildings are built on soil that's sandy and not conductive. So we always recommend sink your ground rod outside of the building at a drip edge where we know there's a reasonable probability that that the ground is going to be conductive and can actually pull those ions away. If you do a ground rod inside your booth, I recommend just sink a second ground rod about 18 inches away. Now you got 2 ground rods down in the soil. If you connect your megger between the 2 ground rods and you get low resistance, that's telling you that the earth is conductive. It will actually pull the charge away.
Now, I talked to my husband about this morning, and I said, "What, do you have any questions about ground?" He goes, "No," but when we set up our booth and moved into the new shop here, are you a fan or not a fan of connecting your ground to the building? So what he did is, when you have a metal building, those pilings and, those.
Yep.
So he just drilled a hole in that, and then it got exposed, the metal there.
So here's the ground path on a building. Okay, it all starts with a ground rod outside the building. Okay, that ground rod by electric code, so this is something that you can't get a approved permit on.
Right.
A ground rod has to present a certain resistance, low resistance to ground, okay? But that's connected up to your electrical control panel, okay? Your electrical control panel uses ground to get you your neutral. That's different than a building. A building, it does not present a good ground.
Okay.
Because there's not a clear path to a ground rod in the earth, okay? The building might have some pilings on it, but any metal that's going down into earth is encapsulated in concrete in your foundation. So it's really not. Honestly, if you were to cheat and not sink a ground rod, the best place to find a ground is not your building, it's your cold water pipe. Because your cold water comes to your building through this long path of underground pipe that is giving you that ground. So if you got a cold water pipe close and you don't want to sink a ground rod, in a good, better, best environment, best is a real good earth ground rod. Better is, a cold water pipe is somewhere between good and better.
Okay, good to know.
Yeah. Nailed on a cold water pipe is if they use somewhere along the line, whether it's at your water softener or wherever in your water path, if they use an isolating union, that means the cold water pipe in the plant doesn't take that path because it's blocked through that isolating union. It won't actually take you to the grounded part.
Okay.
So always use a true earth ground, sink a rod. Home Depot sells them for pennies, it's more than pennies now. But.
And I think you have a slide on that too, just showing.
Yeah, I have and so that's what a ground rod looks like. That's sunk on the edge of our building. When water comes down the building, it goes down this crack. My soil is very conductive, and that's what it looks like on the outside. It comes into the building and goes to the booth right here. That's a bolt that goes to the outside of the booth. Where this wire's connected. So, one of my favorite things. So if you've painted a whole bunch of parts and you walk up to them to point to a defect or a blem on a part, showing somebody we got a little problem there, you get your finger close enough and that charge jumps to you. So zap, you get it. The other thing, if you're powder coating and while you're coating, you're hearing this snap, 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 that's 100% proof and evidence that you don't have a good ground. What you have is a charge that's building up on your parts and your hooks. And somewhere along the line, there's a little micro crack in the powder coating surface. And when there's enough charge, that charge will find that micro crack and actually get to earth ground. And that's that snapping sound. I had, in one class I taught, I asked the question, do you guys hear snapping when you're powder coating, because I'll get 2 or 3 people to raise their hand, and that's proof positive you're not getting ground. One guy raised his hand in the class and he says, yeah, that's the only way I know my electrostatics are working. And I thought, well, that's not a very good way to find that out. So
no, it's not.
yeah. And this was a video. I don't know that I can. Let me see if I can show this here. This is example of static discharge right here. Now you see that there, right? Now
Yikes.
that's not going to hurt anybody and cause any trouble, because that's being created by the powder hose itself, where the powder going through that powder hose is tribocharging. So the hose is getting an electrostatic charge buildup on it, and it finds that little path right there to discharge it. If that was discharging in near the spray zone of a gun, there's enough energy in that arc that if you have the right blend of powder air concentration, that you can actually get ignition. So
yeah.
So, and when I talk about quality, the 3 things are film thickness, and more than film thickness, film uniformity.
Yeah.
And then getting into Faraday's, and all of these things relate to a phenomena called excess free ions. And if you just Google that, you can find out excess free ions at 100,000 volts. The corona charge field at the end of the gun has about 80% excess free ions. These are ions that don't have a powder particle to charge, but they stay attached to an air molecule.
Mm-hmm.
Those air molecules are just like the powder. Once they get something extra hanging from them, they want to get rid of it. So they're all fighting for that same surface. And that's where you get, if you got an excess, a high amount of excess free ions, that's where you get all of these issues.
Mm-hmm.
And that's for another day, another class.
Yeah, okay.
I talk a little bit about average film build. You know, you get a spec from a customer and he says, we need an average film thickness of 3 mils. Well, I can deliver that average 3 mils with a whole bunch of surface that's at 1 mil and a whole bunch of surface that's at 5 mils, because if you average them together, it's 3 mils. Mm-hmm. But clearly a surface that's got very thin film here and very thick film here, you're going to have different mechanical properties. You're going to have different electrical properties. You're going to have probably at 1 mil, if you're painting an orange or a yellow, you're not even hiding metal. So
right.
While you meet the average film thickness spec, you got a terrible surface. If you look at the bottom example, if you got a bunch of 2.9s and a bunch of 3.1s, your average is 3 mils, and inarguably that's a much better, much more uniform surface.
Yes.
So I bring up standard deviation. I give them a little statistical work here, right, in the presentation. Standard deviation is how you determine how good an average is. If a standard deviation is really low, then then that average number is a really good average. It's more like the lower equation here. Mm-hmm. If standard deviation is real high, that means your spread of data is real wide, more like this one.
Right.
And oh, by the way, modern day film thickness testing equipment can actually give you, if you take 8 data points on a part, it'll average the mil thickness measurements, and it'll actually tell you what the average mil is and what the standard deviation is. So that's something that people might not know.
I didn't know they could do that. That's great.
Yep. Yeah, that's all. Everything's digital nowadays. Most anybody's equipment can do that for you. This is some data that Colleen provided me based on the study that we did. This is the variation in film thickness here on a poorly grounded part. So you can see you have a lot of parts that are down here at 2 mils or 2 microns, and you have a bunch of parts up here that are at 12 microns. Clearly, that's a poor surface. You come over here where the part was well grounded, they did surface sometimes I can say that word, sometimes I can't. Profilometry, okay? Mm-hmm. And here you got a nice uniform range of film thicknesses. So I mean, inarguably, ground has a significant impact on surface quality. I mean, it's inarguable. The data is there to support it. This was a study that we did here, and I'm going to skip to the next slide here.
I like this one here. This is a good photo.
So what we did is we took a whole bunch of panels and we hung some from string, cotton string, and some from good clean metal hooks. And we did it randomly. So it wasn't like we did 4 or 5 poorly grounded ones in a row. We just randomly did it. And here's a perfect example of a poorly grounded part not getting coated because the part right next to it was properly grounded. And as we got to the edge, okay, the spray coming out of the gun saw ground here and no ground here. So the powder flowed where it saw the ground, and that was over here. And you clearly, and if you measured the film thickness on this part, which we did, we had templates made up here. We measured all this data, and what we found was clearly that on the ungrounded parts, we were not getting a good film thickness versus the grounded parts.
Is this the one where you you used a string instead of a hook?
Yeah, right here you see that's a piece of string. That's not.
Yeah, yeah.
Yep.
That's how you ended up getting it that way.
There was no way that part had a ground.
Right.
But you can see even though it had no ground, it did get some powder on it, right?
Right. Yeah.
So you're thinking, okay, I'm good, and you're looking at these edges here. If there was 3 or 4 parts in a row that weren't grounded, you wouldn't see this effect except on the end ones where either the previous part was good ground or the new part coming in was good ground. If you had a whole bunch of ungrounded stuff, you wouldn't see this.
Right.
Because there'd be nothing to rob the powder away from it.
Right.
So you could run all day long with ungrounded parts, bad hooks, and you could successfully get powder on like I did here, right? The problem is here it's 1 mil, here it's 1 mil, here it's 4 mils, here it's 6 mils, here it's 8 mils. The uniformity goes away without ground. And cost, so again, if I have a poorly grounded part and I'm trying to do one, let's say 3 mils, I'm going to have a whole bunch of ranges of parts on that part that have 5 or 6 mils and a whole bunch that have 1 mil. And oh, by the way, as I'm painting that surface, I'm putting the same amount of powder on. So anywhere we had a low number, that just said the powder wasn't sticking. It was still coming out of the gun. So where does it end up? It ends up on the floor. Bad transfer efficiency. Where it did stick, and I got these 5, 6, 7 mil buildups, powder was effectively transferring, but now I have mechanical properties. If you exceed the range on a TDS, the range of film build, if the TDS says these properties are valid between 2.5 and 4 mils, and you start putting powder on at 8 or 9 mils, you don't have the mechanical properties. You don't have the flex properties. Everything goes away. So, holistically, you want to stay within that range. The best way to stay within that range is having a good quality ground. Because without it, all bets are off. I mean,
I like how this is a great analogy here.
Yeah, this is a real good one because, people that are painting and having poor ground, they're seeing light parts at the end of the line and they're coming up and bitching to their painters that they're painting light. So what do painters do? They turn up the powder output and start throwing as much powder as they can so that they don't produce light parts. Well, that's taken your film range of 2.5 to 3.5. You're putting 3.5. You're putting 3.5 on most of it, and so you're operating at the high end of the acceptable range. And if you do that, you're actually increasing your cost because if 2.5 mils is satisfactory, it would cost you this. But if because of poor ground, you're constantly running on the high side, you're putting extra powder out, and that extra powder is money out of your pocket. So,
yeah, in terms of cost or passing it along to a lot of times if we're doing a special order powder, we're just ordering a pound or 2 from Prismatic or Columbia or, it's, you're not really thinking that, it's not necessarily on the top of your mind, but it could be, especially if you have some leftover powder, you could make more money on it next, like you could charge your customer again. So,
but I would bet you if you got 1 pound of powder from Prismatic and you're painting this part, you're praying that you got enough powder, right? That you don't run out of powder before the part's coated, right?
Okay. There is that too, yes.
So why pray? Why rely on praying? Put a good ground on there and get maximum transfer.
Good point, John.
So it's not in this case, it's not cost. It's about avoiding having to talk to the big guy upstairs.
There has been a few times where we've prayed, yes.
Oh, I know. Trust me. I do some G jobs here, and so I'll get a 1 or 2 pound sample from a powder guy, and I got this big table to do, and I'm thinking, oh God, please don't run out. Please don't run out. So, and the insurance that you're going to optimize the powder is having a good ground.
There you go. Yep. There you go.
So what else I taught? This is just some different examples. I don't care whether your ground wire is solid wire or stranded. If you go on the blogs, you'll see thousands of differences in opinions. Some guy will be adamant you have to use a solid ground wire, or another guy will be adamant you have to use stranded. You got to be 6 gauge, you got to be 10 gauge.
Yeah.
Honestly, as long as you can get a path to ground, it doesn't matter whether it's solid or stranded. The difference there is stranded is more flexible. It's easier to move around and bend and get what you want to do than solid. The difference between 6 gauge and 10 gauge is if I've got a little short 10-foot run of wire to go to ground, I can run with the higher gauge number is the smaller wire. So if I've got a short run, I don't worry about the resistivity of the wire. I can use thinner, smaller wire, 10 gauge. If I'm running my ground rod 100 yards or 100 feet, I want to make sure I don't have a drop off in ability because I've got this long resistance ground. So I go with the bigger wire. That's all. And for most of the batch guys, DIY guys, most of them are probably, if they don't have the ground hookup in their booth, it's going to be just outside the plant, 20, 30, 40-foot run. I just go with 10 gauge, 8 or 10 gauge. Don't worry about getting anything heavier. This is one important point that
oh yes, this
added
is good.
to the presentation, and that is all soils are not created equally. And some soils, picture a soil that's just big rocks. There's nothing in between them, just a bunch of big rocks. That's not going to give you a good ground. There's very little contact area between the rocks and your ground rod. So it's going to be very poor. So think about what your soil's like. If you got sandy soil, you're probably in an optimizing environment, you're going to sink 2 ground rods instead of 1 because one's not going to present enough ground to you. If you're in clay, moist soil, topsoil, that kind of stuff, you're going to be good with 1 ground rod, but it's something you need to be aware of.
Yeah. I was going to talk to you about, I love this photo. This is such a great photo. And it's,
this explains what I just said in pictures. Here we're sinking the ground rod the same distance, 3 foot into the ground. They're using a ground tester here to test the groundability of that rod. And what they're finding is in sandy soil, the resistance is 750. You get down here into good topsoil, moist soil, the resistance is only 122 ohms. Remember, the lower that number, the better the ground is. So clearly here, you're going to get better conduction to ground by using a sandy or not non-sandy soil, a good conducting soil. Then I talk about how deep we sink the ground rod. Okay. And so this is the same soil here. This is the same soil. We sunk one 1.5 foot down, 3 foot down, and then 7 foot down. And as we had more ground rod area in the soil, the resistance went down. So, somebody says 8 or 10 foot, I'm going for 10 foot every time. I get that extra 2 foot of rod I'm going to bring my resistance down. It's really important. Here I talk about testing. I'm looking here. If I'm sunk in moist soil, I'm going to have almost zero or very close to zero resistance between those 2 points. If I'm in dry soil or sand, I'm going to have a number other than zero. I'm going to have a number that's telling me that that my soil is not conductive. And then I think I mentioned too, there's people that will sink a ground rod in their booth and they'll know that it's not good because it's dry soil, and they'll actually drip water in it. That's not really a good idea, because the water will erode that sand or that soil away. And you're not getting enough moisture down into the ground to actually be beneficial. It makes you feel better, but it's not actually doing you a whole lot of good.
Yeah, I think this is great, because I think there are a lot of Southwest coders, people that are located in the Southwest, where they have these sandy conditions, dry conditions.
So when you're in sandy conditions, you can double the amount of dispersion by sinking a second rod.
Mm-hmm.
But what's important here is in order to maximize that beneficial addition of conductivity, is you have to have the distance between the ground rods equal to twice the submersion depth. So these are sunk 8 foot down. You have to be 16 foot apart. If you put it closer, it's not going to be bad, but you're not maximizing the benefit from sinking the second ground rod.
Right.
And
good visual.
And if you were actually doing this because you needed to present your electrical ground for inspector, not for powder coating, but your electrical ground, you would have to do this. This wouldn't be optional. You would have to have that distance at least 2 times the depth. And actually, some places, in order to get an adequate ground for their electrical system in their plant, they may have to sink 5 or 6 ground rods. But every one of them has to be that same distance apart. And these are just examples. When I went to these plants, everybody said, we've got good ground. Well, no, you don't. You're kidding. If you're going to do this, somebody asked in one of the classes, isn't it better to have a buildup on your hook so that it doesn't rob powder from your part? And technically, the answer to that question is yes. Powder's not going to come to this part here because it doesn't have ground. Now, if you have no ground here, it's going to go everywhere. But if you have if you took a Dremel down in this area and ground it down to bare metal and hung your part on that, now your part's got a good ground, and powder's not going to want to go to this part here where it's got a heavy buildup. So it won't continue to build up, if you will.
Yeah, I was talking to Ross about the hooks and stuff, and I think that's coming up now more. You're going to start talking about hooks and how important it is.
So the choline study proved, the choline study was an engineering study, so it was based on real data, field data. And based on that data, if somebody asks me how many times they should use a hook before they strip it, I'm telling you 2 times, because in the study, when the hook was used once virgin and once with 1 coat on it, our standard deviation of all of our sample points, and we had over 800 data points. We had 20, 40 per piece, 20 pieces. We had 800 data points that generated this data. After the second use of the hook, first time virgin, second time 1 coat, we still had a really nice standard deviation. In other words, the variation in film thicknesses was acceptable.
Mm-hmm.
The third time we used that hook, now that hook has 2 coats of powder on it now, right? The third time we used it, the standard deviation went through the roof, which clearly was telling us that we had a lot of uniformity issues with film thickness, and therefore all the things that go along with it, the bad things, extra cost, poor quality, orange peel, all that stuff comes with it.
Right.
Clearly, in my mind, and in my opinion, and being an engineer, I'm telling you 2 times. Now, is that the gospel? No, but if you ask me from an engineering study point of view, use it twice. After you use it 3 and 4 times, there's the little path that you might have down in there to get your part, uncoated part, in contact with uncoated metal, it goes away after 2 or 3 times. Now, if you want to cheat, go in there and Dremel it out. Put a Dremel at the end of the line. After you pull your part off, have somebody go in there and with a Dremel and do a 2-second little grind, and then you're good to go.
Right. And what size, or were these the size hooks that you used in your test, in your choline test, or?
This was from a couple different customers who, when I walked in, said I've got good ground.
Oh, okay.
The choline test, I think the hooks were 1/8 inch steel hooks, 1/8 inch cold rolled steel hooks.
Mm-hmm.
So small diameter, and I think I mentioned that these were punched metal trays that had sharp edges. So, you know, what we hear all the time, I forgot to mention this. We hear all the time, it doesn't matter if I got powder on my hook, because when I hang this heavy part on it, the powder chips off and I go metal to metal. No, that's not true, okay? You use powder because it's very chip resistant.
Right.
So it's got properties that prevent, when you hang a part on there, that it chips through. And so, you know, we chose the trays from Carrier Corporation because they had sharp edges on the hanging holes, and they also weighed a fair amount. They were fairly good size 16 gauge stampings. And the data based on sharp edges and some mass being hung on hooks, the data doesn't support the fact that you'll chip through that cured powder layer and get down metal to metal. It just doesn't support it.
Yeah, and I think, custom coaters should definitely, I was asking Ross, like he said he spends at least 2 hours of his week, every week. And, all we're doing to, the thinner hooks and those that don't cost that much, we generally just throw those away after we're done.
That's what I recommend.
Yeah.
Yep.
But with those expensive heavy ones, the C hooks and the S hooks that are that thicker one in the previous slide, I mean, those cost so much. It's actually worth the time to spend, at least in our opinion, in our operation, to spend the time, 2 to 3 hours a week stripping, having enough, first of all, and I think you have to order enough hooks to keep you going. You got to have
a set online being used and a set offline being addressed, whether it's in a burn-off oven or a solvent stripper or whatever. You can't rely on one set of hooks, because you're going to be handcuffed and you're not going to strip them. You're going to leave. You need to make production, and you're just going to keep using them.
Yeah. And I think that has a lot to do with it as well. So yes, ground is arguably the most important aspect of a successful powder coating company.
It is. And the key word successful, again, you can go without ground. I mean, I say you can go without ground with a lousy gun, with lousy powder, in humid environment and everything else, and you can still powder coat. Yeah. But you're not doing it effectively or efficiently. For successful powder coating, ground is one of the major, legs on the chair. A good ground, a good gun, a good booth, good powder, those are your legs. But a 4-legged chair with one of them missing without ground, it ain't stable. So just think of it that way.
Yeah, and this is pretty much it, right, on your slides. So let me switch over, because what I was kind of clever today. And before we got started,
you want me to unshare? Let me unshare.
Yeah, go ahead and unshare, because I'm going to share Facebook groups post that I made actually about a couple hours before we started.
When you were having your breakfast, right?
Yeah, I'm like, I got to get this question out, because I have an expert on the show today. And so I wanted to share my screen here to this page. And so I sent out, I'm a follower of and involved in some groups on Facebook, and I put out a couple of different ones. This one is UKC Army powder coating group. And I'm not sure how many members are in it, but I just sent this one out. So I got a lot of comments on it. So let's just run through. Can you see my screen, John?
Yep. The ground between earth and my number 6 wire clip is fine. Like to know maintaining.
Yeah. So
yeah. So honestly, that first question there from Bill kind of addresses that slide I had that showed our cart with the part hanging from it from a hook. So literally, the insurance is understanding that there has to be a continuous path to his clip, and he knows his clip is connected to ground. But what happens after the clip? So really, it's just a matter of understanding that it's got to be metal to metal everywhere something changes. Between the clip and the cart, the clip's got to be on bare metal, not on painted metal. Between the cart and the part, those hooks have to be, in a perfect world, no powder on them at all. In an imperfect world, at least ground out so we know we got metal. And one of the things that people miss on hand carts like this is you got to look at both ends of that hook, okay? Because you're conducting through the cart, through the hole that you're hanging the hook in. The hole could have a powder built up on it. The hook could have powder built up on it. You know, and if you focus too much on the hook connection to the part, you're going to forget about that connection. So you really need to pay attention to the entire path.
Yeah. And he also, so then Tom Russo, he's an avid follower of the show and in several of these groups and stuff. He asks, why does the main beam of my building ground better than true earth ground? That's a good question, because I brought that up earlier. LOL, does the river nearby help ground the footing of the building better than the rod itself? And we kind of just addressed that with what Ross had done. And it's funny because we actually have a canal back here too, which is where he's grounded. Behind, just behind the building here is a canal. I don't know if that has, if you want to try to attempt to answer that one, or,
Well, I would throw the question back at Tom. Why isn't his earth ground actually getting him an earth ground? I mean,
yeah.
I would, if this was me and I'd really like to study it, I would check with a megger between his ground rod and his building steel and see if there's a high resistance between those two. And then I'd start questioning. So let's go back. So the ground rod is typically 3/8 inch diameter. So it has a fixed surface area. If it's sunk in the same soil as his building, and I don't know how his building is actually getting to ground, if it's, if he's got some kind of connection that takes metal from the building deep down into the soil, that metal is going to present a whole lot more area to the ground than his little 3/8 inch ground rod is. So, I mean, I wouldn't disagree with him. I would love to know the number between his ground rod and his building. What's that resistivity in there? What's that reading? But at the end of the day, if he's convinced that his building is a better ground, then I would go for the best ground. I would connect to the building.
Right. Yeah. I mean, and at that point, it might be worth it for Tom to invest in one of those mego. What are you calling megometer? Megometer.
Let's call it a megger. It's a megger.
Megger. Okay. And we're not talking.
I'm a ground fanatic. I'm not a ground rod fanatic. I mean, I will tell you that the probability of a building being a better ground than a rod stuck in is low. In Tom's case, may be the exception rather than the rule. But
yeah. Unknown Coatings, who's the admin and creator of the group, he wants to know, are you an expert on grounding or an electrical engineer?
I'm an industrial engineer by degree. I'm not an electrical engineer. So I would never profess to be that. I've just studied ground. Okay, I understand the principles in that. An electrical engineer, actually not an electrical engineer, a power engineer, okay, someone who's used to power transmission would be a much better educator of the science behind ground. But I'm talking to powder coaters, and if I got into all these scientific terms in that, it's
it'd
not
be
going
like,
to work.
It's not even relevant, right? It's just, they're just trying to solve their problem and move on.
So I'm not an electrical engineer.
So let's move on to Blake Stoltz. And he's asking, I'd be interested in knowing what the ideal threshold is for an acceptable ground, what it is.
That's actually a really good question. 0 is the right answer, and he recognizes that.
Right.
But in general, from a safety point of view, from codes, from the NFPA code, from the OSHA 1910-107, the number's 1 megohm.
Okay.
You have to be below 1 million ohms to ground in order to qualify and be within the code in OSHA. If you're above that, it's bad. That could be the same threshold you use from a quality point of view, but you know, my instinctual answer would be you'd want to be closer to the 0. You know, 500,000 ohms maybe would be acceptable. But
so he's saying on his second question, though, he says, where are you going to start seeing that resistance on the second half of that question?
So you, first of all, with a megger, you're not going to be measuring 10 ohms. You're going to look at grander numbers. You're going to be, you know, I mean, I wouldn't trust a reading below 250,000 ohms, and it's not important. At that point, it's not important. If you're reading 3 or 4 megohms, then you're in a range where A, you're violating code, and B, you know, you're going to have quality issues. But anything below 1 million ohms, I think you're fine.
And I think one of your slides actually had that, where the meter reading was like 3.4 or something like that.
Yeah, it was 3.4 megohms. Yep.
Okay, so I think the first question we've already answered, or was Bill's question, was the ground and the number 6 wire. Let's see, there's more comments coming in. I'm interested in other ideas to do if your soil is so hard that you can only get a grounding rod down about 2 feet, maybe 3. That's a good question.
So you'd have to know why your soil's so hard. Is it hard, dry clay that you can't drive your ground rod through? That should tell you you got a bad ground opportunity anyways, but this is where you start sinking multiple ground rods.
Okay.
So if you can only get it down 3 foot, go 6 foot over and sink another one, tie them together.
Yeah.
You know, and then in a good, better, best, sink a third one and tie them all together. All of them are 2 times the depth apart, right? So that's how I would deal with that.
Okay, that's fair enough. Casey Lavac, given you have a good ground, what causes body shocks when you grab the rack to roll it in the oven?
Okay, if you have a good ground and you still get a shock when you go grab the rack, that's probably some ion buildup on your body, okay? That's discharging to the good ground when you get close to it. So I would be looking at my shoes. I would be making sure I'm not preventing it. You know, I'd be looking at my gun. There's a ground wire that comes in the gun cable that connects to that gun. If that ground wire is broken, now you don't have a good electrical ground. There's a lot of things I'd look at.
Lots of things to troubleshoot there.
Yep.
Yeah. Okay, Jimmy O'Malley. Why am I grounding just fine with a strap attached to the cart and using just the clip from my sprayer, not even using my ground rod anymore?
Well, you'd have to ask Jimmy.
Jimmy.
to demonstrate that he's doing a good coating job, that he's doing it as efficiently and effectively as possible. Because this comes back to, I can powder coat with no ground, okay? Am I doing a great job? Do I have uniform film build? Am I not seeing back ionization and that? That ground from your cart is connected to an electrical ground, which is connected to a ground rod at your service entrance where your power comes in. So theoretically, you have a good ground, but in a good, better, best environment, that ground is clouded with a whole bunch of other stuff going on versus a direct earth ground.
Yeah.
Oh.
Okay, Jimmy, please follow the tips that John's given in this webinar today, because I think.
And he said, and weirdly having some of my best finishes lately. Maybe
I don't know, Jimmy.
Maybe the planets are all aligned perfectly. I don't know. But
Jimmy, you take too many chances.
Yeah, I don't quite know, how to address that, to be honest.
Yeah, maybe Jimmy can reach out to you directly.
So the next question addresses the point I made with a volt ohm meter, okay?
Yeah.
And it's not that a volt ohm meter is bad, but it may give you a false indication that you have no ground when you really do when you measure it at a higher voltage.
Right. So maybe we can find a link. Maybe you can share the link or tell me again the name of the, and we'll Google it here. What's the name of the brand that you recommend?
Oh my God, it's not Triplet. I'll send you a link to it.
Okay, send me a link and then we'll put it in the webinar
you can go to most test equipment suppliers. There's a testequipmentdepot.com is one source, and you're just going to ask for a megger. That's all.
Yeah.
And anybody will know what it is.
Okay, so that's all the 10 comments from that one. Let's see if there are any other groups. I think we addressed everybody in that one. Yeah.
Well, you got a lot of groups there.
Oh, yeah. Okay, here's a couple more. Where do we listen to your show? You can go to rosscote.com, ROSSKOTE, Shane. This is the powder coating tips tips and tricks for industrial professionals. Dan Fitzpatrick, he has a really nice YouTube channel that he helps other powder coaters with. Have him explain the proper way to check ground to rack, hook, rail, etc. with a meter.
Well, and I kind of went over that a little bit. So first of all, you on a megger, there's two leads coming from it. One lead has to be connected to a known ground. It's where you can actually see the wire coming in from an earth ground. You connect the lead to that, and then you're literally connecting the other lead. If you want to bypass all the connection points and go straight to the part, you can do that. Check your resistance. If it's low, then you don't have to check any further. If it's high, then you'd go to the hook and connect it to the hook and see. You're going to work it back to where you see the deficiency in the ground path.
That's a great point.
Everything has to be electrically connected in order to have a good ground.
Right.
And I said earlier, if you just check your part to your rack, you're not verifying ground, you're verifying conductivity.
Okay. Yeah.
You have to have one lead connected to a known earth ground.
Okay. Robert Soka, where do we connect ground from the gun? Where do we connect ground from earth? Can we ground the booth? What is the best method to ground the part? How many grounds do you need? Okay, so I think this one's already been addressed. We actually did pretty well with addressing all of those. So Robert, I hope
the gun is electrically grounded from the ground wire that's in the cable that's attached.
Right. Yeah. Right.
There's got to be a conductive surface on the gun, whether it's the handle or the trigger. And actually, that brings up a good point. You know, powder is hygroscopic, right? Hygro, hygroscopic. It wants to suck moisture to it, okay? And painters sometimes complain about their hands getting dry. A lot of women will put a latex glove on to not get the dryness, and that latex glove is a barrier between their body and ground. So if you've got a latex glove on and you're powder coating, you're not grounded anymore, okay? If you got rubber soles on your shoes, that's even worse. Now you got zero.
I imagine a lot of people use rubber soles.
Well, but not all rubbers are created equal, right? So, but even with the rubber sole, you still have something if you've got hand to the
contact.
Gun, right?
Okay, so change your shoes and don't wear a glove.
Yeah, or if you wear a glove, they actually make conductive gloves purposely by a conductive glove, and then you're going to be okay. If you don't want to do that, just cut a hole in the palm, a small hole, so part of your hand touches the handle.
Okay. Let's see. I think we just got one more question. Ground is like a ground. Nathan Parks, laugh my ass off. Okay. So Brandon was trying to help Nathan's question there. All right. Well, these are great. These were great. I'm going to stop the share because most of these we've already answered. They were all good questions. Some of them we had touched on earlier. So tell that I'm going to, before we wrap up, I want to share my screen again with Parker Ionics. Let's talk about your company and what do you sell in case anybody doesn't know. Tell us more about your company and let's do a plug for you.
Okay, so Parker Ionics is a supplier of application equipment, powder guns, manual, automatic, powder coating booths, and we can do a whole podcast on proper booth design because there's a lot of bad booths out there. And so we supply, we're part of the PCI. We're part of the advanced training rotation. So once a year, along with Nordson, Gema, and Wagner, we host their 202 training. So we're of that genre. This is our 8500 series here that actually, I believe this week we got final FM approval on our next generation handguns that we'll be announcing here shortly. We still sell our analog, you know, the old regulator and gauges. We still sell that because that's 3 generations old. That technology has our advanced Corona charging technology, pulse power built into it. And pulse power, and we won't go in depth here, but pulse power fundamentally lets you charge powder with high voltage, which equates to good transfer efficiency, as I said earlier, and low current simultaneously. So our guns can put out 10 to 20 microamps at 100,000 volts. So we bring the microamps down to avoid orange peel, to avoid Faraday cage penetration issues. We bring you low current, which is beneficial for proper coating, and high voltage, which is beneficial for transfer efficiency simultaneously, using a technology called pulse width modulation. And anybody can Google that. There's a thing to Google pulse width modulation. It's used in dimmer switches. It's used in plating lines. It's used in welding equipment. Welding equipment controls the heat of the weld using pulse width modulation. High voltage, so you get a good arc, but low current, so you don't burn through parts. We use the same technology. That's what makes us different. And it's a demonstrable technology. We sell all different parts, guns, gun movers. We just were moved to a different division of our parent company, and it's the Parker engineering side of the business. We sell complete paint lines from soup to nuts, anywhere from coat lines to Our parent company built, you'll love this, Wuhan, China. Honda just 3 years ago built a brand new assembly plant in Wuhan, China, and our parent company did the entire paint line for them. So
wow.
We have that technology and knowledge between our headquarters and our North American branch here. So we do a little bit. And Abe, my buddy Abe, he's a good friend of mine. He's a high school friend of mine. He's a dead ringer for Abe. And if Abe,
he does,
who has no experience powder coating, can lay down a uniform thickness of film with our gun there, anybody can.
Let's talk just, if you have the time, real briefly, let's talk about the Powder Coating Institute, what it's doing to sort of bridge the gap. There was a recent article. It's been, I've been bringing it up a lot in the recent podcasts that I've done, which is this one here with the education.
Yep.
And we just had a meeting about membership. I'm not sure if you were in that one or not, but
that's the first one I missed in about a year and a half.
Yeah, you weren't there. That's right.
Yep.
And I guess, as the voice of custom coating, which is kind of what this podcast has been about from the get, in building a community for custom coaters. I'm beginning to think that PCI, and correct me if I'm wrong, but they do say they have a custom coater, that this is for custom coaters.
Right.
But I'm kind of wondering if their definition of custom coaters is slightly different than what we view ourselves as custom coaters, and maybe we can talk about what is a custom coater.
I think your view of a custom coater is PCI's view. Okay, it's someone who paints somebody else's parts, okay, and does it on a daily basis. Now you can take the custom coater name and you can subdivide that. You can go down to the one-man shops. A custom coater could be a one-man shop. It could be a 40 or 50-man shop, right? Mm-hmm. There's a big range in there. We do have a special membership category called custom coaters. They have their own board, if you will. They have their own seat on the PCI's board, a dedicated seat just to custom coaters. What we struggle with every year is we've got, I think, 129, it ranges from 120 to 200 custom coater members, okay?
Right.
We'd love to see that number higher because we have a voice for all these people through the board and through the organization. The PCI is the only membership organization that's dedicated 100% to powder coating. Okay,
mm-hmm.
We don't do liquid. We educate only on powder coating. Okay, mm-hmm. And so our membership is the best of the best when it comes to knowledge, products, etc. What we run into with the custom coaters is a lot of the small shops, the owners are painting themselves, okay? They don't have 4 or 5, they're out there. Their time is consumed running their business, and it's hard. The benefit of belonging to the PCI is participating, like you do, sit on committee, interact, mingle with other members. You learn from your peers, okay? Yes. And speaking of peers, we have the peer groups for the custom coaters, which is a great program where you're linked up with a group of other custom coaters, not in your geographical territory because they'd be your competitors, mm-hmm. but in a non-geographical territories. So you can, the peer groups will go and have regular meetings at one of the facilities, and these are a peer group. And so what they do is they actually grade the facility on how well they're doing. And so they're all intermingling, they're all educating each other. Oh, God, you pick up an idea. That's how he protects his hooks from getting powder on it. And you walk away with knowledge.
Yeah.
You don't get that if you don't belong to the association. And if you belong to the association and you don't participate, you don't get it either. So the key is joining it. It's not expensive to join PCI, but do more than join it, participate. And a lot of times that's where the hard part comes in, because they just don't have time to do it. But
yeah,
meetings are all online now through Zoom calls or Teams meetings. And if you can't sit at your desk and participate in a membership meeting or an educational committee meeting or a technical meeting, we've got all sorts of committees that anybody who belongs is welcome to participate in. And you're going to spend an hour every 2 or 3 months among your peers. I just, to me, it's a no-brainer if you're a powder coater to belong to the organization.
Right. I mean, if you are looking to grow your company, understanding the greater industry, I mean, that's one of the reasons why I've joined PCI, is just to kind of understand the greater industry and how it runs, how it works, and stuff. And these webinars have been really great, which is where I picked up, you know, I'm not a powder coater, you know that, but, you know,
You're doing
I really,
service.
I did get up at the crack of dawn. It was 5 a.m. in my time zone to attend the webinar. And I totally found it fascinating, which is why I asked you to come on the show and stuff. And I think that, you know, if this platform, if this Powder Coater podcast does anything, it's just to kind of share that knowledge so that you learn something new that you never knew before about PCI or about grounding or about scaling your business this way and that way, and how others have done it. You know, it's just sharing the information just to get it out there. It's to kind of open everybody's mind up to potentialities.
But remember one thing, I'm one point of contact. Okay, if you join PCI and you actually do more than just join it, but you participate in an hour committee meeting every couple of months, or you interact with other members, you're getting multiple points of contact, multiple opportunities to learn, okay,
yeah,
within one organization. So I mean, I'm very opinionated on ground, but there's probably a dozen other people within PCI that will may give you a different tip, okay? So
yeah,
but it's participation.
It is, but it also, you know, it's not, you know, the wealth of knowledge behind. I mean, if you did have some kind of question about something or other, I mean, they would hunt it down and find that answer for you. And I had Kevin Corson on the show, and that's exactly what he is out to achieve.
The powder coating handbook, the Bible, I don't know if you got one on your desk there.
We do.
That's generated by the membership. We sit together. I sit with my competitors, and we write the electrostatic portion, and we write the booth portion. And I'm with Nordson, Gema, Wagner, and we're taking the best knowledge of all of ours, and that's what gets into that handbook.
Yeah.
And that for a participating member, when I say participating, come to the show, you know, sit on committee. You get the benefit of these very knowledgeable people, and they're all willing to share their knowledge with you. So
yeah, and I think that that's been kind of the barrier that I think it might be more of a mental barrier for us custom coders that are kind of the DIYer type or garage type or have a small mom and pop shop, is just knowing that that information is out there and you can grab it. You know, you can have access to it. You can go and seek out the answer to the questions you have, but it is kind of difficult. And, you know, again, the show is just to try to break down that barrier so that people like us know that we can, you know, ask people like you who have just, you know, eons of energy, you know, of education and knowledge to share with us. And that's all I'm trying to do, is just kind of eliminate that burden, you know, by opening it up for at least for conversation.
One of your safest ways to find speakers is just look within the educational committee of PCI, because these people anybody who's an authorized speaker has been vetted in their area of expertise, right? So, so like we said at the beginning of the podcast, you know, you can get information on a dozen blogs, but I can take you to one that some of the suggestions are so off the wall, but they're so confident in the way they present it that, you know, how do you vet that? How do you trust that guy? Well, you know, the PCI is not going to give you bad information.
Right.
And that.
It's the source.
Yeah. Good vetted source. Yep.
I think, I mean, if there's one thing, and there's so many things that I, with an institute like PCI, or with what PCI is so much has changed in just use of Facebook and everything. I mean, you were amazed at how many groups there were on powder coating, and I swear to you, there's like a new one started every week. But there are some that are more participatory or more active than others, and I think part of what I wanted to convey to Kevin and PCI and just membership in general, and I have talked to Karen from GEMA, who's also on that committee as well, is that the users, Karen, yeah. Is that the users today, especially on platforms, social media platforms that we're all getting used to and on all the time, is that people want that information brought to them. They'll ask a question and they want answers. So it's different from forums where you would go and seek your question or submit your question, and you would look and hunt and find. But today's users are just wanting that information presented to them all the time, just right there. And that in itself is kind of difficult for such a more static platform as joining meetings and this and that. So please consider that at PCI, because I know you've been involved in that. How are we going to, the educational article that came out in Powder Coated Tough magazine was a valid one, but it's not the only one, especially coming from, I guess, the bottom up, if you want to call a group of custom coders from the bottom. Is just how are we going to engage these people? How are we going to keep the topic relevant for their day-to-day problems?
So the webinar series that we have with PCI is the foundation of a much bigger educational program that's going to be deliverable through the internet at some point in the future. I can't address a lot of it, but there are education modules that are coming. So
I've heard that. Yeah.
And the beauty of that is, the receiver can, at their leisure, on their schedule, absorb the material, right?
Yeah.
You lose a little bit of the interactivity of question and answers when you're doing it that way.
Right.
But we're also studying how we can deliver them in a real world situation. So real time, I should say, not real
time. I think that's a good word to use, because everybody learns at different paces. We all know that. Some are visual learners, some need to hear their audio, learn things more that way. Some are very kinetic learners as well. And there needs to be a wide variety, and there also needs to be a interactiveness to the point that when the user or the student or the guy with the question actually can grasp and answer the question, or I don't know what the word is. It's like, make sure that they absorb what they just read, heard, or touched. You know what I mean?
Oh, well, so one of my favorite sayings is, when I start a class, I say, okay, I'm going to sit here and talk to you, but you're going to learn more from that guy over there asking a question that I then answer, okay? And what's inherent in human beings is they're always afraid to ask a question because they're afraid it's going to be dumb and they're going to get ridiculed. And there is no dumb answer. The dumb answer or the dumb question is the one that doesn't get asked, okay?
Right.
Because I guarantee you, if you've got a question, there's at least one other person in that room that's got exactly the same question, and he's also afraid to ask it. So, and that's the part of the real time that I think is valuable. Now, you can capture that still in a webcast or a podcast like you just did. We had questions that were brought up, we addressed them, and I guarantee you every question that was asked through that blog was in somebody else's mind. So
right. I was amazed. I mean, I just looking at that now, I just posted that 3 hours ago, and look how many questions we answered or had when we.
Well, feel free after this that if they come in or send me the link, and I'll kind of peek in and out and jump in and answer when I can. So
yeah, I'll invite you, or I'll figure out. Some of them you need to be invited to, and then others you can just go and join.
Well, if you remember, if you do a screenshot and send it to me, I can get you an answer. And
yeah.
So, yep.
Yeah, awesome.
Good.
Awesome. Well, I know you've got a call coming through from.
Yeah, I got to go get a bite to eat,
Japan.
and I got a Zoom call with Japan at 7:00 Eastern time here. So.
All right. Awesome. Well, thanks again, John, for coming on the show. I'm sure we're going to maybe have you come back again to talk about some other things, but it's just so good to kind of meet you in person. I know we kind of see each other in the Microsoft Teams thing.
Yeah, everybody's got their cameras turned off. Yeah. So you don't actually get to see anybody. So this is great. Keep up the good work.
Yeah.
I think what you're delivering to the industry is very valuable. And keep putting experts in front of the camera and doing like you're doing now. It's really good.
Thank you. It was good to hear that. Thank you. All right. Well, have a great day. Aloha.
Thank you. Aloha. Bye-bye.
Bye.